everyone, welcome back to GDC classes. So dear students, as you all know, this was the time for organic chemistry weekly test, and today we are having the weekly test of organic chemistry, and we are going to see what are the questions that were asked in this weekly test from the organic chemistry. Let's start. The topic for this organic chemistry weekly test was like classification and nomenclature, bridge ring systems, bond parameters, hybridization, reaction intermediates, and inductive effect. So these topics were there, the questions from these topics. So let's get started. The first question we are having is the assertion and reason based question, you all know. So the assertion here is benzene is a carbocyclic compound. So benzene, as you all know, it's a carbon derived compound, it's a hydrocarbon, it's an aromatic hydrocarbon. So the benzene structure is something like this, and this is direct from the classification part. So this is your benzene, where we are having carbon atoms, 6 carbon atoms in a ring structure where 3 pi bonds are there. So yes, it's a carbocyclic ring. This carbocyclic ring means it's a homocyclic ring where all the atoms basically that are participating in the ring formation are only and only carbon atoms. So yes, it's a carbocyclic ring. So assertion is right. The reason, it has 3 pi bonds in the cycle. So this is not the correct reason for the assertion. Like yes, it is a homocyclic ring, it's a carbocyclic ring, since all the atoms that are present here in the cycle ring formation is just a carbon atom. So that's why it can be known as the carbocyclic ring. But the 3 pi bond is not at all the correctly explaining your assertion, but yes, that is also correct. This is also correct statement, but not the correct explanation of the assertion. So both are correct. Both assertion and reason are correct. Both assertion and reason are true, but reason is not a correct explanation of the assertion. So the B must be the right answer for this question. B is the correct answer. It's a carbocyclic ring. Yes, it's a homocyclic ring where all the atoms are basically the carbons that are making this structure. Next question we are having, how many unhybridized p orbitals remain on sp2 hybridized atom? We are having a sp2 hybridized atom. How many unhybridized p orbitals are present here? So as you all know, carbon is having one s, that is 2s, and 2 p orbitals is having again the 3 structures. So there are 2 p orbitals, 1 2 3, this is 2 p orbitals, and 2s orbital, that is 1. So 1 here and 3 this, 1 this and 3 this. So they basically mixed up in such a way, like if we are having 3 p orbitals and 1 s orbital, that will be giving you sp3. If 2 p orbital and 1 s orbital mix up, it will be having 1 unhybridized p orbital, 1 unhybridized p orbital. If 1 s and 1 p mix, it will be giving you sp plus 2 unhybridized p orbitals. So 1 unhybridized p orbital will be present for the sp2 hybridization. So the question was, how many unhybridized p orbitals were there? So it will be 1 for the sp2, 0 for the sp3, and 2 unhybridized p orbital for the case of sp. So the correct answer will be B again. B will be the right answer. It will be having 1 unhybridized p orbital in this sp2 hybridization. The next question is the IUPAC name of the following compound. We are having a IUPAC name of this bicyclic system. It's a bridge ring system where we are having these two are the bridgeheads. Now the numbering will be started either from this bridgehead carbon or from this. We knew like both of the sides are having the same number of carbon, so we can be starting, let's suppose it's 1. You can give this 2 or this depending on your like will. 1 2 3 4 5 and 6. So we are having total 6 carbon atoms, means hexane will be the right answer for the word root. So hexane, like here we are having octane, so that is wrong. Here we are having 2 carbon system, here we are having the 2 carbon system, and in the center we are having the 0 carbon system. So it will be 220, 220. So wrong. Okay, so this is the right answer. It is a bicyclo 220 hexane. So D will be the right answer. D will be your correct answer. So this is how you are going to nomenclature this is structure of the bicyclo system, the bridge ring systems. Next question we are having, CH3 CH2 Cl undergoes a homolytic fission to produce. So we are having a alkyl halide. We are having a homolytic fission, means the homolytic fission will be having something like this kind of cleavage where we are having the free radical formation. So homolytic fission will be giving you free radicals. And free radicals are produced only when we are having homolysis. So Radical and anion not possible. Both of the species that are that is breaking the bond here will must be having the free radical formation. So charge, this is heterolytic fission, this is also having the heterolytic fission. Here we are having radical and radical. So both the species break in such a way like both of them are having the radical formation, free radical formation. So yes, A will be your right answer here. A will be the correct answer, and homolytic fission will always give you the free radicals, while the heterolytic fission gives you the charge forms, the plus and minus forms. What is the correct order of stability for the following carbon ions? We are having the carbon ions. We are having tertiary carbon ion. You can directly name it as a tertiary carbon ion. It's a 2-degree carbon ion, and this is a 1-degree carbon ion, and it's a methyl carbon ion. Methyl carbon ion. The order of stability will be directly proportional to minus I group and inversely proportional to plus I group, directly attaching to that particular carbon ion species. We knew here there are 3 alkyl groups that are directly bonded with the carbon ion carbon. So that's why we can name it the least stable carbon ion. Then this one more stable, and the most stable. So the most stable carbon ion is methyl, followed by 1-degree, then 2-degree, and then 3-degree. So the fourth will be the most stable one. This is wrong, this is wrong. Fourth, okay, then followed by 3, that is a 1-degree, 3 here, so this is also wrong. B is the right answer. B will be your right answer for this question. So yes, B is the right answer for the case of carbon ion. Suppose this is the case for the carbocation, then 3-degree carbocation due to greater plus I effect of alkyl groups will be the major stable one, followed by 2-degree carbon ions, then 1-degree carbon ions, and then the methyl carbocations, my bad, for the case of cations. Okay, so if you are not able to join to the weekly test where these tests are actually happening, you are not able to find that particular batches, you have simply visit the GDC classes application, go to the batches section on the downward side of the application interface, click on the plus symbol, click on this plus symbol, and you will be asked a batch code. You have to simply put the GDC quiz batch code in small letters without any space. So just type this GDC quiz and click on the OK. You will be have a wait period for the 2 to 4 hours. In the 2 to 4 hours, you will be having to see this batch, that is GDC weekly test, that is happening every Sunday. So you now have to simply go to the test and you simply attempt this particular test that is live only on the Sundays. Next question we are having, what is the molecular geometry associated with the sp hybridization? So molecular geometry associated with the sp hybridization, that is bent shape, trigonal, pyramidal, tetrahedral, or linear. So the sp hybridization is in such a way where both the sp orbitals, two orbitals mix up in such a way that both the orbitals are arranged linear in structure. So it will be linear for the case of sp. So sp will be having the linear geometry. sp2 will be having trigonal planar geometry. Trigonal planar geometry, while the sp3 can have 3 kinds of geometry, that is tetrahedral, pyramidal, or V-shaped, that is bent shaped. V-shaped, that is also known as bent shaped. When we are having 2 lone pairs, that structure will be bent shaped. If we are having anion or a lone pair, that will be pyramidal in shape, and tetrahedral in all the structure are having just a bonded ones. So that will be having tetrahedral. So for the sp, we are having linear structure. Both the hybridized p orbitals will be having the linear structure. Next question we are having, the IUPAC name of, we are having a structure again. Again it's the bicyclosystem. This is the bridgehead and this is the bridgehead. Both of the sides are having the same kind of carbon atoms, same number of carbon atoms. So suppose this is 1, this can be 2, 3, 4, 5, 6, 7, 8, or 2, 3, 4, 5, 6, 7, 8. You can start from any of the sides since both of them are identical. Total we are having 8 carbons, so this is not the correct, this is not correct answer. Either it could be the A or the D option can be only the right answer of this question. So you can start, you are having 1, 2, 3 carbon on this side, 1, 2, 3 carbon on this side, and the central ring, the central chain we are having 0 carbons. So 3 carbon this side, 3 carbon on this side, and the center chain is having 0 carbons. So bicyclo 330, bicyclo 330, no 4 chain, so that is also wrong. 330, yes, bicyclo 330 octane, that is D will be the right answer. D will be the right answer for this question. Most stable carbocation is, so the most stable carbocation, now we are having carbocation, we are having alkyl group, that is CH3 group, that is having plus I nature. Now we are having minus I bromine, minus I chlorine, and minus I of this fluorine. Stability of carbocations is directly proportional. Stability of carbocation is directly proportional to plus I, inversely proportional to minus I group. So we are having the carbocation. Yes, we are having the stability. We are asked about the stability of carbocations. So that carbocation which is having the least or lesser minus I groups, that will be the most stable one, or the group that is having the highest plus I groups, that will be the most stable one. So we are having this plus I group, all of them are minus I. Presence of minus I decreases the stability of carbocation, while presence of plus I increases the stability for the carbocation. So A will be the most stable carbocation. A will be the right answer, the most stable carbocation. Okay, suppose you are asked about the order. So the most stable will be A, followed by which of them will be having the least minus I effect. Fluorine, due to highest electronegativity, will be having the highest minus I power, then chlorine, then bromine. So the order will be something like A is the most stable, followed by B, followed by C, followed by D, due to most strong minus I power of fluorine, that will be the least stable cation. Okay, most stable will be A, that is A. Okay, ethyl cation. Most stable carbon ion is, so the carbon ion, stability of carbon ion is directly proportional to minus I group, inversely proportional to plus I groups. Okay, so this is the stability of carbo anions. How it is decided? We are having CH2 minus CH2NO2. Okay, so this is the strongest minus I group, one of the most strongest minus I group if we are dealing with the neutral structures. CN, carboxylic, and the fluorine. Okay, most stable carbon ion. Carbon ions are stabilized by the presence of minus I groups. Here we are having the strongest minus I group, that is separated just by a carbon atom. Here again, just one carbon separates the CN, one carbon separates this carboxylic, and 1, 2, 3 carbon are separating this carbon and with the fluorine. So the most stable is the presence of the most powerful minus I group. So here we are having the strongest minus I, that is just present after the one carbon distance. So distance in these three is same, since we know like inductive effect is distance dependent factor. So A will be the most stable carbon and most strong minus I will be seen for the A, that is NO2 is present direct after the one carbon gap of the CH2 minus the carbon ion. So A is the most stable one. A will be the most stable structure. A followed by B, followed by C, and then followed by D. Okay, that will be the right answer. Which of the following free radical is the most stable? Free radical, which of the following free radical will be the most stable? Methyl radical, primary radical, secondary or tertiary radical. Free radical is having the stability by having the greater number of alkyl groups, greater number of alpha hydrogens. So the tertiary radical will be the most stable, followed by the secondary one, followed by the primary, and then the methyl. So the most stable will be the tertiary radical. Most stable will be tertiary radical. D will be the right answer. Tertiary radical will be the most stable. The hybrid state of carbon atom which are attached to a single bond with each other in the following structure. We are having CH2, double bond CH, single bond C, triple bond CH. So we are asked about the hybrid state of carbon which are attached to a single bond. So this carbon and these two carbons are attached by the single bond. So what is the hybridization of this carbon? It's having the sp hybridization due to presence of two unhybridized p orbitals that are basically forming that particular 2 pi bonds, that is sp hybridization, and this carbon is having sp2 hybridization since the one double bond. So one of them is sp2 and the other is sp. Wrong, both are sp2, so wrong. Only A option is having sp2 and sp. So yes, A will be your right answer. A will be your correct answer for this question. A will be the right answer. Molecular formula C4H8O2 represents. We are having C4H8O2. It's an acid only. an ester only, an alcohol not at all possible since we are having two oxygen atoms, an acid and an ester also. So acid and ester, both of them are having two oxygen atoms. Suppose let's make some acid from this given formula. We are having C4H8, so CH3, CH2, CH2, C double bond O, OH. So this is what we are having: 1, 2, 3, 4 carbon, 3, 2, 5, 2, 7 and 1, 8, 8 hydrogen and 2 oxygen. So C4H8O2. Can we form any ester from this molecular formula as well? Yes, we can. How? Suppose we are having CH3, C double bond O, O, CH2, CH3, 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 1, 2, 3, 4, 4 carbon, 3, 3, 6 and 2, 8 hydrogens and 2 oxygens. So yes, we can form esters as well as an acid. So yes, D is the right answer. D will be the right answer for this given question. You can form carboxylic acid as well as ester since both of them are having the same general formulas for the acid as well as for the esters. The higher homologue of a dimethylamine, we are having dimethylamine has the structure, the higher homologue. Suppose we are having methyl, nitrogen and methyl, so it's a 2-degree nitrogen atom, 2-degree nitrogen. So the higher homologue must be again a 2-degree nitrogen containing. So if a higher homologue can be having something structure like this, you can add one CH2 group and CH3 either on this side or on this side. So this is the higher homologue. Again, for the higher homologue of this structure, you have to add another CH2 group, another CH2 group. So suppose this, it's a 3-degree nitrogen, not at all possible. It's a 1-degree nitrogen, not at all possible. This is a 2-degree nitrogen with 1 CH2 addition. Yes, that is correct. C is the correct answer. I guess so. Again, it's a 1-degree nitrogen, so that is also not possible. So this is wrong, this is wrong, this is wrong. Only this nitrogen is having a 2-degree that was given in your question. So yes, C will be the right answer. C will be the right answer for this question. Okay, C will be the right answer. Which of the following carbocations is the most stable? Which of the given carbocation will be the most stable? Again, the most stable carbocation: methyl carbocation, ethyl carbocation, tertiary, 2-degree carbocation or the 3-degree carbocation. So carbocation having the stability order of 3-degree carbocation, most stable, followed by 2-degree cations, then 1-degree cations, and which is more stable than the methyl cations. So 3-degree, that is D, will be the right answer. Tertiary butyl carbocations, that is a 3-degree carbocation. That is a 3-degree carbocation. How does the inductive effect influence the dipole moment of a molecule? Inductive effect, how it is going to influence about the dipole moment? It has no effect on dipole moment. It creates a temporary dipole moment. It creates a permanent dipole moment. It cancels out the dipole moment. So inductive effect is a partial polarization factor. It is having a partial polarity, and at that polarity must be a permanent. Till that particular atoms or groups are bonded with each other, that dipole moment, that polarity must be present on that particular structure. So it creates a permanent dipole moment. Partial positive, partial negative separation due to electronegativity difference at that particular bonded atoms and in that bond. So yes, that will be having the permanent polarization. So C will be the right answer for this question. Okay. Okay, so the GDC weekly test, when it is actually happen? So this GDC weekly test is scheduled on every Sunday at 5 p.m. Every Sunday on the 5 p.m. at the GDC classes application. I just told you in the earlier slides. You simply have to go to the GDC classes application, click on the batches section and enter the batch code GDC quiz, and you will be able to attempt the further upcoming GDC weekly test. And this weekly test is totally free of cost. You can attempt the questions every Sunday, and each Sunday we are having different subject weekly tests having 50 questions. And after finishing your test, you can go, you can watch here on the GDC classes channel of the detailed explanations with all the questions that are asked in your GDC weekly test. The next question we are having is structure of the compound whose IUPAC name is 3-ethyl 2-hydroxy 4-methyl hex 3-ene 5-ine oic acid. Okay, let's have The first, what was the first thing, first substitution? That was 3-ethyl, and we are having carboxylic group, so oic acid. Okay, so the oic carbon, that is carboxylic carbon, must be the first carbon. Suppose this is your first carbon, so first, second, third. Do we are having any ethyl substitution on the third carbon? Not at all. Not at all. Do we having any 2-hydroxy? Do we having the hydroxy substitution on the second carbon? No, that is not here. Here 1, 2, 3. Yes, we are having 2-hydroxy, but not we are having 3-ethyl. Not at all. So this is also not correct. 1, 2. We are not having any 2-hydroxy group. That is also not correct. 1, 2. Okay, so we are having 2-hydroxy. This is the third, and third we are having CH2, CH3. Yes, we are having 3-ethyl. We are having 2-hydroxy. Okay, and 4-methyl. So 1, 2, 3, 4. 4, we are having the methyl group. Yes, that is also correct. 4-methyl. Then we are having hex 3-ene and 5-ene. 3-ene, yes, we are having the 3-ene and 4-5. We are having 5-ene oic acid on the first carbon. Yes, C is the right answer. C is the correct IUPAC structure of this given name. C will be the correct answer. In which of the following multiple bond is absent? Which structure is having absence of the multiple bonds? CH3C triple bond in. So this is CH3C triple bond in. This is having multiple bonds, so that is not the correct answer. HCl, okay, so that is also having the double bonded OH. That is also not the right answer. CH2N2, CH2 double bonded N minus plus. So that is also having the multiple bonds. That is also not correct. C3H8, yes, that will be correct. CH3, CH2, CH3. It's a propane. So yes, D will be the right answer. D is not having any multiple bonds. So yes, the absence of multiple bond. This D will be the right answer. Which is weakest base? Which will be the weakest base? Weakest base. So the presence of lone pair on nitrogen. Lone pair on nitrogen decides the basicity, and the basicity is directly proportional to plus I group, inversely proportional to minus I group. The presence of plus I group increases the electron density on the nitrogen, the lone pair electron density, while the minus I decreases this lone pair electron density on the nitrogen atom. Now suppose we are having the weakest base, that is the structure that is having the highest minus I will be the least basic, will be the least or the weakest base, So this is benzene ring. Okay, this is alkyl group, this is NO2, and this is CHO group. So this is having the minus I, this is also having the minus I nature. This is also having the plus I, and this is and followed by this benzene. Now suppose this is the minus I, this structure is having minus I nature, that is separated by the CH2 group, means minus I will be slightly lesser since it is separated by a carbon. Nitrogen is having the plus I nature of this alkyl group, so this is having a better basic strength. Now this NO2, the strongest minus I power, that is separated by a single carbon, and this NH that is having just direct CHO, the minus I directly attached with the nitrogen, distance dependent. Inductive is a distance dependent effect. Here minus I nature of this CHO is in direct bond with the nitrogen. So the minus I power of CHO will be the highest among all the given structure. Highest minus I means the weakest base strength. So this D will be the right answer. Yes, NO2 is the strongest powerful nature of inductive, but inductive is following this DNP concept. That is, first we have to see the distance. Lower the distance will be having the highest minus I phenomena or the plus I phenomena. Then we will be seeing the number, greater number of particular inductive groups will be having the better effect, and then we will be looking for the powers. So here the distance was least The minus I group was directly attached with the nitrogen. So D will be the right answer, the weakest base. The weakest base. Which of the following intermediate is known for having a triple bond within a benzene ring? Within a benzene ring, which of the given intermediate will be having the triple bond? So benzene with a triple bond. This is a benzene. It's a benzene. Since we are asked about the intermediate in which a benzene is having a triple bonded structure, so that will be a benzene. Means C will be the right answer. It's a very common question from the intermediate benzene structure. What percentage of S character does an sp hybrid orbital possess? So sp orbital, sp2 orbital and sp3 orbital. sp orbital is having 50% of S character and 50% of P character. 50% of P character. sp. sp2 is having 33% of S character and 66.66% of P character. Here sp3 is having 25% of S character, 25, and 75% of P character. So the sp will be having percentage S character. sp is having 50%. sp is having 50%. So C will be the right answer. C will be the right answer. Aniline C6H5NH2 is a weaker base than ammonia, primary due to this is aniline and this is ammonia. This is ammonia. We know basicity is directly proportional to presence of plus I groups and inverse to minus I groups. This benzene is having minus I nature, while here we do not have any plus I or minus I group. The hydrogen bond will be taken as the reference bonds. So this minus I power of the benzene reduces the electron density on the nitrogen, that will be lowering the basic strength of that particular aniline basicity. So the minus I nature, minus I effect of the phenyl group, minus I effect of the phenyl group is responsible for the weaker base strength of the aniline with respect to the ammonia. Why is carbocation at a bridgehead position in a bicyclic system highly unstable? A carbocation on a bicyclic system is highly unstable, since after getting the carbocation on the bicyclic system, this carbon must be having sp2 hybridization, and sp2 hybridization structure must be having a planar structure, that must be present on a single plane, a flat structure. That is not possible for the case of bridgehead structures. The bridged compounds must be having a non-planar geometry. So that's why we cannot place a carbocation on the bridgehead carbon. We cannot put the carbocation, or we can also not able to have a double bond. In simple, you can directly, so like a sp2 hybrid bridgehead is not at all possible till 8 carbon ring. If the ring is of more than 8 carbons, you can have that, since it's a that can be having the different conformations possible, and this is the rule, that is the Brett's rule. That is due to the Brett's rule. This is due to the Brett's rule. This is Brett's rule. What is the geometry of a molecule with sp3 hybridization? A sp3 hybridization will be having the geometry of linear, that is for the sp, trigonal planar, that is for the sp2, and tetrahedral for the sp3. Octahedral is not at all possible for the sp, sp2, sp3. So tetrahedral will be for the sp3. Tetrahedral will be for the sp3. Which of the following substituents would most effectively stabilize a adjacent carbocation? We are having the carbocation, and stabilizing a carbocation means the group must be a plus I group. Plus I group, the alkyl groups. NO2 strong minus I. CHO minus I. OCH3 is also having the minus I nature. Chlorine is also having the minus I nature. But among all them, the minus I will be the least for this OCH3 group. this OCH3 will be having the least minus I power. NO2 will be the strongest one, followed by CHO and the halogens. While this OCH3, the minus I power of this OCH3 will be the least one. So, most stabilized carbocation must be of the OCH3 bonded. The OCH3 bonded group, the OCH3 bonded carbocation will be the most stable one. Which type of bond is characteristic of an sp3 hybridized carbon? Which type of bond? One triple bond. Triple bond is a characteristic of sp hybrid atoms. One double bond is a characteristic of sp2 atoms. Only single bonds, yes, that is true for the sp3. That is true for the sp3. Two double bond is not at all possible for the sp3. So yes, sp3, C will be the right answer. C will be the right answer. What is a reaction intermediate? What is a reaction intermediate? The starting material in a reaction is known as substrate. That is known as substrate. The final product of a reaction, that is the product. That is the product, the final product. A substance that is formed in one step and used up in the later step. It is formed in one step and used up in the later step. Yes, that is correct. Means that is not present on the final stage of your reaction. So yes, that is an intermediate short-lived fragment produced in a step that is used in the later or the subsequent further upcoming steps. So yes, that is correct. A substance that speeds up the reaction and is but not change, that is the catalyst. That are catalyst. So that is not the right answer for this question. C will be the right answer. C is the correct answer. C will be the right answer. How many intermediates are there for the organic chemistry? Cations, anions, radicals, benzene, nitrene and carbenes. What is the IUPAC name of this compound? We are having again a bridge-head system, bicyclosystem. We are having bicyclosystem. 1, 2, 3, 4, 5, 6, 7, 8. All of them are having 2 carbon chain. 2 chain, 2 carbon chain, 2 carbon chain. Total 8 carbons are there. So bicyclo 2 octane. 2. This is wrong. This is wrong. It's a tricyclo. That is wrong. Bicyclo 2 octane. A will be the right answer. Next question is, what is the approximate bond angle in a molecule with sp2 hybridization? So the approximate bond angle for the sp2 hybridized orbital will be 180, 120, 109 or 90. So 180 is for sp hybridized, 120 is for sp2 hybridized, and 109 is for sp3 hybridization. So the sp2 will be having the trigonal planar and 120-degree bond angle. The 120-degree bond angle and trigonal planar symmetry. Because a carbocation has a positive charge, it will act as, how does a carbocation will be acting? It will act like a nucleophile, it act like an electrophile, free radical or a base. So remove this base. Actually the carbocation that is having the electron deficiency, the structure will be electron deficient. It means it will be having love for the electrons. That structure will be having love for the electrons. Love for the electrons means it will be a electrophile. It will be a electron loving. It's a electrophile structure. So electrophile like a structure will be known as the carbocation. It is having the properties for a electrophile. Okay, electrophiles. Why are reaction intermediates usually difficult to isolate? A reaction intermediate is usually difficult to isolate from a reaction due to they are very large molecules. No, not at all. This is not the correct reason. They are highly reactive and exist for a very short time. Yes, that is correct. They are short-lived fragments. So that's why their separation is not at all possible. So yes, that is correct. They are always gaseous, not at all possible. They are uncharged. That is also not the correct explanation. So B is the right answer of your given question. B will be the right one. How many hybrid orbitals are formed during sp hybridization? So during sp hybridization, how many hybrid orbitals are formed? So during the hybridization of sp, we are having 2 hybrid orbitals. We will be having the 2 hybrid orbitals and 2 unhybrid orbitals, 2 unhybridized p orbitals. Which of the following is an example of a cyclic compound? Cyclic compound example: ethane, that is a chain structure. Isobutane, chain structure. Acetaldehyde, chain structure. Cyclopropane, yes, it's a cyclopropane, so cyclic structure. D will be the right answer, cyclopropane. Compounds containing only carbon and hydrogen are known as. So the structure that are having only carbon and hydrogen are known as hydrocarbons. They are hydrocarbons, and can saturated or unsaturated. So the structure, the molecules that are made up of only carbon and hydrogen, that will be named as the hydrocarbon ones. That will be the hydrocarbon ones. So B is the right answer. B will be the correct answer. What is the hybridization of the carbon atom in formaldehyde? We are having the formaldehyde, HC double bond OH. So the formaldehyde, this carbon is having the hybridization state of, it is having one sigma bond here, one sigma bond here, one sigma bond here. So we are having 3 sigma bonds plus 1 pi bond. This presence of 1 pi bond and 3 sigma bonds leads to the sp2 hybridization state. sp2 hybridization state. So the carbonyl carbons are always sp2 hybridized ones. Hybridization is a theoretical concept used to explain the color of compounds. No, color of compounds is not the correct use for the hybridization. The mass of atom, that is also not the right answer. Observed molecular symmetries and bondings. Yes, the hybridization tells you the arrangement of atomic orbitals that are actually making the bonds with some other atoms. So they are usually tends to identify how a particular atom is bonding with other atoms and what kind of bonds they are actually forming. So C is the right answer. C will be the right answer. How can you quickly determine the hybridization of a carbon atom? So the hybridization of a carbon atom can be quickly determined by just counting the valence electron. That is not the right approach. Yes, you can use the number of valence electron for your identification of the hybridization, but just by counting the valence electron, you cannot able to find the hybridization, correct hybridization state. By counting the number of pi bond it forms, that is also not correct. Just by counting the number of pi bonds, you cannot able to identify the accurate hybridization state. It can be a method to check the hybridization, but not the correct approach for this. By counting the number of atoms and lone pairs it is attached to. So how many bonds that particular atom is making and how many electrons in the form of lone pair or negative charge it is having, that can actually gives you the hybridization. So yes, C can be the perfect method for identifying the hybridization state of atom. So yes, that is the correct one. C will be the right answer. C will be the right answer. An sp hybridized carbon atom can form 2 sigma bond, 2 pi bond. Yes, a 2 sigma bond and 2 pi bonds. That is correct. 4 sigma bond for the sp3. 3 sigma bond and 1 pi bond, that is for the sp2. And 1 sigma bond and 3 pi bond. 3 pi bonds is not at all possible for a single carbon atom. So A will be the right answer. 2 sigma bonds and 2 pi bonds. Okay, 2 sigma and 2 pi. As the s character of a hybrid orbital increases, what happens to the bond angle? So the percentage s character is directly proportional to bond angle, angle of bond. As the percentage s character increases of a hybrid orbital, the bond angle also increases. For example, a sp3 carbon is having the bond angle of 109 degree, let's suppose. sp2 is having the bond angle of 120 and sp carbon is having the bond angle of 180 degree. So as the percentage s character increases, the bond angle is also increasing. So yes, it increases. It will be increasing. It will be increasing. Which of the following statement about the inductive effect is correct? Which of the following statements are correct? It is a temporary effect, not at all possible. Inductive, resonance, hyperconjugation, these all are the permanent effects. It involves the delocalization of pi electrons. No, it involves the displacement of sigma electrons. It is a permanent effect involving the shifting of sigma electrons. Yes, that is right answer. It extends uniformly throughout the entire carbon chain. No, it's a distance dependent effect. And as the distance increases between the atoms, this effect is also decreasing, or this effect also decreases. So that is also not correct. So A, B, D are wrong. C is the right answer. C will be the right answer. It's a distance dependent effect, permanent effect, polarization effect. And in this, the sigma electrons are displaced in a bond. Which of the following describes a group that shows a plus I effect? Which of the following describes a group that shows plus I effect? Electron withdrawing group, they are minus I group. They actually pulls the electron density. Electron donating group, yes, they are electron donors, so yes, they are having the plus I effect. Electron negativity halogen, they all are minus I groups. So yes, B will be the electron donating will be having the plus I nature. Okay, plus I effect. Which of the following groups exhibit a negative inductive effect? Minus I, methyl, that is alkyl, plus I nature. This is again a plus I group. Nitro is minus I group, ethyl is a plus I group. Okay, so nitro minus I. Nitro will be having the minus I effect. How does the strength of an inductive effect change with the distance from the influencing group? How does the strength of inductive effect change with the distance? As the distance increases, the influence of this inductive that will be decreases. So it increases, it remains the same, it decreases. So yes, as the distance increases, the effect of this inductive will be decreases. An electron withdrawing group minus I effect attached to a carboxylic acid will generally electron withdrawing group. So acidic strength is directly proportional to minus I group, inversely proportional to plus I group. As the number of minus I group increases, the acidic strength of a particular acid will be in the increasing order. As you know, like minus I effect, electron withdrawing groups are directly attached to the carboxylic acid, that will be increasing the electron, that will be increasing the acidic strength. So it increases the acidity, yes, that is correct. Decreases, that is for the plus I groups. If we are having a plus I nature group that is attached with the carboxylic acid directly, that will be tends to decreasing the acidic strength of that particular acid. Not affecting its acidity, that is wrong. Make it base, that is also not correct. A will be the right answer. A will be the right answer. An electron donating effect attached to an amine will generally, so base strength is directly proportional to plus I group, inverse to minus I group. Acidity is directly proportional to minus I group. Basicity is inversely proportional to minus I group and directly proportional to plus I group. So as the number of plus I effect groups increases on a particular nitrogen, that will be increasing the basicity of that particular nitrogen containing compound. So it increases the basicity. It increases the basicity. The plus I groups increases the basicity. A will be the right answer. IUPAC name of the given structure, we are having again a spiro center. It's a spiro compound. Spiro compound. So always start numbering from the smaller ring. So 1, 2, 3. You can either name this 4 or this 4. So this is, let's suppose 4, 5, 6, 7. We are having 7 carbon. Decane is not correct, undecane is not correct, undecane is not correct. Heptane, yes, we are having 2 carbon chain here and we are having the 4 carbon chain here. So spiro 2, 4 heptane. A is the right answer. A will be the right answer. Which of the following halogens has the highest minus I effect? Which of them will be having the highest minus I effect? Iodine, bromine, chlorine or fluorine. The highest electronegative atom fluorine will be having the highest minus I, followed by chlorine, followed by bromine, and then we are having the iodine. So the highest minus I effect will be for the fluorine containing, that is D will be the right answer. D will be the right answer. Organic compounds are broadly classified into which of the two main categories? Saturated and unsaturated compounds, natural and synthetic compounds, open chain, acyclic and closed chain cyclic compounds, broad classification, benzenoid, non-benzenoid. This is under carbocyclic or homocyclic rings. Natural, synthetic, that is not a broader classification for the carbon containing compounds. Saturated and unsaturated are only and only for the aliphatic or acyclic compounds or cyclic compounds. But open chain, acyclic and cyclic, this is some of the broadest classification of the organic chemistry. So yes, C will be the right answer. C will be the right answer. Broader classification, cyclic or acyclic. What is the key application of inductive effect? Determining the color of a compound, predicting the boiling point of alkanes, comparing the acidity and basicity of organic compounds. Yes, that is correct. Calculating the bond energy. No, C is the right answer. Inductive effects is having the direct correlation between the acidic strength of a acid and the basic strength of a base. Okay, so C will be the right answer. How does the inductive effect influence the stability of a carbocation, especially with a negatively charged carbon? carbon ions inductive effect. So inductive effect, electron donating group increases the stability. Electron donating groups increases the stability of a carbocation. So this is not the right answer. Electron withdrawing group, that is minus I group, increases the stability. Yes, that is correct. For a carbon ion, with respect to a carbon ion, electron withdrawing groups always increases the stability of a particular carbon. And the reason behind this is like very simple. Suppose a carbon ion is reactive only and only because of the presence of extra electrons, the highest electron density on that particular carbon, that is actually responsible for the reactivity of that carbon. And suppose if we are having an electron withdrawing groups, the person that can pulls the electron from that particular carbon ion, it means that is decreasing the electron density, the increased electron density, that is decreasing. It means that yes, that particular structure will be having the better stabilization of that particular carbon ion. So electron withdrawing groups minus I group increases the stability of the particular carbon ion. Which of the following compounds is the strongest acid? Which of the following will be having the strongest acid? Acetic acid, chloroacetic acid, dichloroacetic acid, and the trichloroacetic acid. Both are acetic acid derivatives. Now, if we are having 3 chlorine, suppose we are having the 3 chlorine atoms. Now the presence of these 3 chlorine atoms tends to have the strongest minus I nature. And the minus I power must be increasing the acidic strength of a particular acid. We know very well. Greater the number of minus I groups, more will be the acidic strength of particular acid. So this D will be having the most acidic nature. So that will be the right answer. So this is all about your weekly test questions that were held today on 12th of October. I hope you all have attempted all the questions and most of them must be the correct one. So thank you so much everyone for joining with us, connecting with us. We will be meeting you again with some newer questions, newer concepts and some newer topics. Thank you so much. Stay tuned. Thank you.